So, I am currently working on this very big and important project, and so far it has been a decent success, but there is just one problem. It needs an EPROM. And I have already built this little EPROM programmer just with an Arduino and some breadboard and shift registers and stuff. But the thing is, this EPROM programmer actually does not work. So instead, I have built my own manual one. It, of course, has the EPROM, some switches to select the address that you want to read or write from, the data that you would want to read, and some LEDs to show what data is stored on that specific address, an indicator LED, and an LED to show whether or not you are in the programming mode or not. Let's go ahead and turn this thing on. I plug it in. Incidentally, this cable is just from a 5-volt power supply, specifically the 5-volt USB output of my oscilloscope. It's actually more like 5.5 volts, but it doesn't care. And let's just go ahead and turn this thing on. As you can see, the lights light up, and let's turn out the lights so that we can see this a little bit better. And we are currently at address 0, and address 0 is just all ones. So let's move on to address 1. Now it's got a little bit different data in it. Address 2, it's got different data. Address 3, it's different. Address 4, 5, 6, 7, and so on. And this is just data that I had already programmed into the EPROM. But anyway, let's go ahead and see what happens when I flip this last switch over here, because the address is controlled by all of these switches except this last one. So let's go ahead and flip that. The orange LED turns on. It looks a bit more yellow in the camera, but in real life it's actually much closer to red than yellow. But anyway, now we can go ahead and set data, and it will show up on the LEDs. So like if we wanted to write I don't know, maybe this to address 0, then we can do that. Maybe if we want to write the same thing to address 1, 2, 3, 4, and now we can go ahead and flip all these things off and switch it back into the regular mode. And you can see that this data has now appeared in address 1, 2, 3, and 4. Well, 4 apparently is still the same because unfortunately this little button doesn't always work very well, so sometimes you need to press it a couple times in order for it to actually write the data into the address. But anyway, it still works good enough for me. And if you're wondering how you could use this EPROM programmer in place of a real EPROM programmer that you could plug into a computer, this binary value, which is just represented by these LEDs, can also be represented by 1s and 0s. So I won't be surprised if you could write some sort of program to translate a string of hexadecimal numbers into a stream of binary numbers, which you could then read and program into it manually without having to deal with EPROM programming software. But, of course, the regular computer EPROM programmer is, of course, going to be a lot faster and probably a bit more convenient, but this one I have a bit more trust in that it actually has a higher chance of working than my crappy little Arduino down there. But anyway, if you're wondering a bit more detail on how this works, you should go ahead and check out Ben Eater's video. I'll probably pin a card right up there. But just, it's basically just all these LEDs are using their resistors to pull down the data pins when there is nothing connected to them and it's in the programming mode. There are individual pull-down resistors for all of these address pins, which are a bit hidden under all these wires. And the right button is going to be a bit more interesting because it actually has a little capacitor right there. It's a 1 nanofarad, 1 kilovolt capacitor. It doesn't need to be 1 kilovolt. It's just what I had on hand. But when you press this button, it makes a very specifically timed pulse into the right enable pin of the EPROM, which is that one right there. and the write pulse needs to be a certain length in order for it to sustain a high number of write cycles, so that the chip would last longer. And so you need to have a capacitor and some resistors to set an RC time constant, which could work for the write enable pin. Yeah, but like I said, if you want more detail on this, check out Ben Eater's video. Anyway, I think that's about it.